So hello everyone, welcome back to another video. Today we are going to be taking a question from the chapter of quadratic equations. Okay. So first of all, let us read the question, then I will tell you what we are going to do in this question. Okay. So I have to find the number of integral values of a for which this given equation has three integer roots. Okay. For this given equation has three integer roots. So what we're going to do here is we're going to find, like, we are going to use two different methods over here. One is the conventional approach, one is the non-conventional approach, which I found to be better. So please watch both of the approaches to develop your understanding. Okay. So the first approach, the conventional approach, is that, like, whenever you see two different parameters, you think of separating them, right? So that is what I did. I separated, like, the parameters a and x. So what I'm going to get is a is equal to 3x minus x cube. So here I see a cubic polynomial. So what I'm going to do is draw a graph of this. Okay, draw a graph of this, which will be pretty easy. You'll know this thing is pretty easy. So this thing can be written as x times 3 minus x square, right? So now let us proceed on to drawing the graph, and then you'll see what happens. So let us draw the graph now. As you can see, this equation has roots as x is equal to 0, x is equal to minus root 3, and x is equal to plus root 3. Okay. And you can see that this function, when x tends minus infinity, this function tends infinity, and when x tends infinity, this function tends minus infinity. So I'll be having a graph something like this. Okay, so we'll be having a graph something like this, and from here we can infer that it will have a maxima and a minima. Okay, so let us find the value of the maxima and the minima. Also, you can see that this function is an odd function. Okay, so in order to find the maxima and minima, I need to differentiate this function. I'll be having something like this, and from here I'll be having x is equal to plus minus 1. So of course x is equal to minus 1 is going to be the minima, and x is equal to 1 is going to be the maxima. Okay, let us find the value of this function at these 2 points, and then we'll see what happens. So at x is equal to 1, the value of this function is 2. Okay, and since it is an odd function, at x is equal to minus 1, the value has to be minus 2. Okay, fine. So now what we are going to do is see what this thing represents. Y is equal to a. This is y is equal to 3x minus x cube, right? So y is equal to a represents a straight line, since we know that a is a constant quantity. Okay, and more to that, it is an integer. So what we are going to do is draw a straight line and see how many points it intersects. We have been given that there should be 3 intersections, and that too at integers, because this equation is having integral roots. So if the line y is equal to a is above this line y is equal to 2, there will be only one root. Okay, and if it is below y is equal to minus 2, there will be only one root, but we need 3 integer roots. If we draw a straight line over here, we'll be having like 2 equal integer roots, and one root we cannot tell anything about it. We need to find out what happens. Okay, now if we draw a straight line over here, then we'll be having like 2 integer roots over here. We cannot comment anything on the third root, and if we draw like anything between them, we'll be having 3 roots, but we don't know if they will be integers. But what if I tell you, you can tell whether they will be integers or not. Look, if we draw, I'm going to erase it later. Let me show you. If we draw a straight line over here, can you see that one root belongs to 0 to 1? Okay, which means it has to be a fraction, and the other root, it belongs to 1 to root 3. Then this also has to be a fraction. So I can say that if we draw a graph like this, like if we draw y is equal to a between these 2 points minus 2 and 2, this equation is not going to have integral roots. You can see over here also. Here I'm going to have a root between minus 1 and 0, so it has to be a fraction, and here I'm going to have another root between minus root 3 and minus 1, so it has to be a fraction. So what can I infer from this? Let me erase it all. Then I'll tell you what we can infer from this. So what we can infer from this is we need to have, like, we are left with only 2 possibilities. Either y is equal to a is this, or y is equal to a is this, because we are getting like 2 integral roots over here. We need to check the third root whether it is integral or not. Okay, so that is what we are going to do. So let us do that. First of all, let us try a is equal to 2. So what we are going to have here is 3x x cube minus 3x plus 2 is equal to 0. Of course, x minus 1 whole square is the root of this equation, like is a factor of this equation. As you can see, it touches it over here, it touches the graph over here, so we'll be having something like x square plus 1 plus 2x times, here if you factorize properly, you're going to have something like x plus 2 is equal to 0. Okay, so from here I can tell that the other root is going to be x is equal to minus 2, which is indeed an integer, so a is equal to 2 satisfies. Now what I'm going to do is put a as minus 2, okay, and then we are going to see what happens, because that was our another case, right? So what we are going to do is put a is equal to minus 2, and from here, since the function is an odd function, I'm going to get x is equal to 2 as the other root. You can check it if you want. This is going to be our other root, okay? So this thing also satisfies. So what a question asked was, we need to find the number of integral values of a for which this equation has integer roots. We found only two values of a, which is a is equal to plus minus 2. So 2 is our answer. Now coming on to the better approach which I told you about. So in this approach, what I'm going to do is I'm not going to separate a. I'm just going to write this expression x cube minus 3x plus a is equal to 0. Okay. I'm just going to write the equation and draw the graph directly. Okay, so here we need to take three cases. Okay, here we need to take three cases. The first case where we can assume that this equation has three distinct real roots. Okay, that is going to be our first case. So if we differentiate it, we'll get like the extrema points at the same points, x is equal to minus 1 and 1, and it extending minus infinity, it tends minus infinity, and we don't know if x is equal to 0 is a root. Okay, for now we don't know if x is equal to 0 is a root, but can you see that if this equation is going to have integral roots and like we have three distinct roots, then the third root has to be 0 in order to have integral roots. Okay, so we can tell that f of 0 is 0. From here we can tell that a is equal to 0, but if a is equal to 0, then the other two roots are going to be plus minus root 3, which are not integers. So this case is rejected. This case is rejected. Okay, moving on to the next method, like next case. Moving on to the next case. So here what we are going to do is we are going to assume that this equation, okay, so I've drawn the coordinate axis. So what we're going to do in this question is, we know that it has like extrema at x is equal to minus 1 and 1. So in this case we are going to assume that it has two equal roots and one distinct root. So for it to have two equal roots, the situation has to be something like this, right? The situation has to be something like this, or let me draw it with a different color over here itself. Or it is going to be something like this. Alright, so these two are the cases which I'm going to get. So from here, like from this case, the blue one, let me write it with the blue color itself. So from here I can infer that minus 1 is a root of this equation. So let us substitute and find the value of a. Okay, so when we substitute, we get something like minus 1 plus 3, which is 2, plus a is equal to 0. From here we get a is equal to minus 2, right? Great. And if we take like the graph drawn in white, what we get is, from here what we get is, if 1 is a root of this equation, then we'll be having something like a minus 2 is equal to 0. So we'll be having a is equal to 2 as our root, a is equal to 2 as a solution. Okay, so I get these two solutions from here. The third case can be that it has like all three equal roots. That is not possible, you know that, right? Or it has only one root, so that is also not possible because we need three integer roots. Okay, so this was our only possible case, last possible case. Okay, so these two will be our solutions. Again we get the same answer.